What is IoT? What is dashboard? Let us explain. First, let's see what IoT means. The term IoT, the Internet of Things, IoT, describes devices with sensors, processing ability, software and other technologies that connect and exchange data with other devices and systems over the Internet or other communications networks. What is dashboards? A dashboard is an information management tool that receives data from a linked database to provide data visualizations. Uses of dashboard: provides at-a-glance visibility, saves time and resources, improves decision-making, easy performance checks and balances, up-to-date progress evaluation. Dashboard reporting needs meaningful metrics.
We're going to create the dashboard app with the name Site Sync and add information from the IoT that was installed in the construction site. Let's look at the process step by step and how the app will function. Let's first look at the parts that we're going to use for this project. In the field of construction, a solid-state LiDAR sensor is a high-tech tool that uses light detection and ranging (LiDAR) technology to collect precise, three-dimensional (3D) data about the surrounding environment without using moving parts like conventional mechanical LiDAR systems. This technology is particularly useful for construction applications since it can quickly and accurately scan construction sites, providing essential information for a variety of uses. A well-liked system-on-chip (SoC) module for embedded systems and Internet of Things (IoT) projects is the ESP32. It belongs to the ESP family of microcontrollers and is renowned for its adaptability, minimal power usage, integrated Wi-Fi and Bluetooth connectivity, and inexpensive price. Internet of Things (IoT) applications and devices can be developed, deployed, and managed using Google Cloud IoT's range of cloud services and tools. It provides a strong platform that enables businesses to scale up the secure connection, monitoring, analysis, and management of IoT devices and data. A component of Google Cloud Platform (GCP), Google Cloud IoT offers a broad range of services to handle various IoT-related issues. Google Cloud SQL is suitable for a wide range of applications, from web and mobile apps to data analytics and reporting systems. It simplifies database management and ensures that your databases are reliable, secure, and highly available, allowing you to focus on building and scaling your applications. It makes it simple to create, maintain, and run relational databases without having to worry about the supporting infrastructure. AppSheet's no-code approach makes it accessible to users with varying levels of technical expertise, allowing them to create tailored applications to meet their specific needs. It's a flexible and customizable platform used across industries for improving efficiency, productivity, and data management. Step-by-step procedure to create the Site Sync app. Let's see one by one. Step 1: Set up the solid-state LiDAR sensor in the construction site. Installation: a solid-state LiDAR, light detection and ranging, sensor setup on a building site requires a number of stages. Determine sensor placement. Determine the best places to install the LiDAR sensor. The locations want to monitor in the line of sight necessary for precise data collecting. Install the solid-state LiDAR sensor in the designated positions securely. To reduce vibration and movement that could compromise data quality, make sure it is securely fastened to a sturdy structure, such as a pole, tripod, or construction machinery. Giving the sensor a reliable power supply. Depending on the sensor model, this can entail plugging it into a regular electrical outlet or, if the construction site lacks dependable power, utilizing a backup power source such as a battery or solar panel. Make that the LiDAR sensor is connected to the internet. The communication used here could be Ethernet, Wi-Fi, or cellular, depending on the sensor's specs. Make that the network connection is dependable and has enough bandwidth to transmit data. To calibrate and configure the LiDAR sensor, adhere to the manufacturer's instructions. This process is essential for guaranteeing proper data collection. Setting the sensor's field of view, scanning parameters, and resolution are all examples of calibration. What are the data that the solid-state LiDAR going to detect in this project? The LiDAR sensor can generate real-time alerts or warnings. These alerts can be communicated to equipment operators through visual and auditory signals, wearable devices, or dashboard displays. Storing the data in the ESP32. Hardware connection. Using the proper interface, connecting the LiDAR sensor to the ESP32 by the proper wiring. Power supply. Make sure the LiDAR sensor has the electricity it needs. This can mean joining it to an electrical source with the appropriate voltage, like a battery or power converter. Programming environment. Set up the Arduino IDE on the computer and programming the ESP32. Arduino code. Create an Arduino code program that sets up the ESP32 so it can interface with and read data from the LiDAR sensor. To communicate with the sensor, you'll normally utilize the proper library functions and communication protocol, such I2C or UART. Sending the connected data to the Google Cloud IoT. In this project we are going to sending the data to the Google Cloud IoT to managing the data from the ESP32 and LiDAR sensor. ESP32 setup. Write program ESP32 device to collect data from the solid-state LiDAR sensor previously. By using the MQTT library to establish a connection with Google Cloud IoT Core. Authenticate our device using the private key generated earlier. Publish data. In the ESP32 code, publish LiDAR data to the Cloud IoT Core using the MQTT protocol. Publish the data to the cloud pub/subtopic associated with the device registry. Pub or sub is a HIPAA-compliant service, offering fine-grained access controls and end-to-end encryption. Take advantage of integrations with multiple services, such as cloud storage and Gmail update events and cloud functions for serverless, event-driven computing. Store the IoT values in the Google Cloud SQL. Create a cloud function to handle the data received from the pub/sub subscription. Design the database tables based on the kind of data that are collecting and the way we want it structured. Process the incoming data in the cloud function, like format conversion, validation, and write the processed data into the appropriate tables in your Google Cloud SQL database. AppSheet integration. Create a new AppSheet account or navigate to the existing dashboard, inserting the Google Cloud SQL database to AppSheet. Choose the tables/views, or other model dashboard like that the client want the data sources from the app. Utilize AppSheet's interface to design app's user interface, UI, using the data from your SQL database. Ensure that the design meets the requirements and visualization needs in the construction project. Steps involved in exporting the AppSheet software design to the SiteSync app. Define how the connected data will be used in the app. Before build our app interface, we will want to specify how our data is being used in the Data tab. Test, share and develop the app. Test the app with various stakeholders, project managers, site supervisors, etc., to ensure it meets their needs and provide any necessary refinements. We can customize the email message and other messaging sources they will receive from AppSheet, inviting them to use your app. From there, they can either download the AppSheet app on their device, or open it in a web browser. Once we've finished making changes to the app, we can officially deploy it, which will activate all the services in the app. Go to Manage Deploy Deployment Check and checking the deployment. Post-deployment, educate stakeholders on how to use the application. Monitor the system for any issues or bugs, addressing them promptly. Ensuring that the entire system, from data collection at the LiDAR sensor to visualization in the SiteSync app, operates seamlessly and efficiently. How the SiteSync is going to work. It is user-friendly, it is a powerful tool for businesses and it allows users to access and interact with specific data, metrics, and functionalities tailored to their needs and objectives. This app sending the notification in the Gmail, WhatsApp, and other messaging sources, daily updates, continue monitoring, store the largest collected data and making the dashboard, neat, pictorial representation of the storage datas. Giving the safety warning notification.